unhealthy and unsustainably produced food poses a global risk for people and planet, and nearly 1 billion people in the world lack sufficient food, and many more consume an unhealthy diet, contributing to premature death and morbidity. Simultaneously, the global food production is the single largest human pressure on Earth, threatening local ecosystems and the stability, for goodness sake, of the entire system. So I probably don't need to also tell you there are some who consider that the current COVID pandemic is a manifestation of the pressure of humans on local ecosystems. But don't worry, a lot of thought and planning has gone into developing a consensus on a set of sustainable development goals for the planet and our survival. Among the 17 SDGs, and you can see that at least 3 of them are focused on food production, on human access to food, and the health of the environment. In other words, food production and its application to eradicate hunger are very much on the agenda. And all over the world, developed and developing countries are researching and innovating to address the big challenges that I talked about. So, building the world we want. How are we going to operationalise the SDGs around food? Well, this recent World Economic Forum report has in its executive summary a series of statements about the problems and the way forward. So we can see that these problems are about looking at the food systems that are not fit for purpose and transforming as needed, looking at how business has a role in driving progress through innovation, new and bold practices being needed, and then social ecological priorities to be at the centre. And they conclude that the future is in our hands. But where do we find leadership? We find leadership and leaders ideally from those who are educated or experienced and who understand what needs to be done. So there is some good news though, so I'm just bear with me while I frame the problem and why you're needed to solve this problem. The good news is that in addition to our mission and World Economic Forum goals, we also have some scientifically validated targets to formulate healthy diets from different combinations of foods, and this can inform our future primary production practices and the sustainable translation of this produce into food products that maximise nutritional supply for all. So, and we also know that the scientific targets for producing the foods we need to eat in a sustainable way, and some of the key indices of environmental sustainability are listed here. So this collective information gives us a framework for optimising and guiding how we will feed ourselves into the future and the transitions that we need to adopt. And you've probably heard this type of information translated into recommendations for sustainable dietary patterns that, for example, in the future are likely to include consuming a higher proportion of plant-based foods, for example. So we now have some missions for training and research that the International Union of Food Science and Technology has defined for us. In this context, we can consider that training is a prerequisite for research and equally is a prerequisite for the role of industry in taking innovations into the marketplace and to end users like ourselves. Now, I won't go through the missions in detail as each one represents a substantial piece of the food supply chain and each one has major technological innovations going on as we speak. But these are the spaces that our masters is concerned with. So if we now look at the skills needed for future success and our quest to modernise the food supply, you can see that some of these are listed here, and I hope that some of you are at least now beginning to see yourselves in these roles in the future. So that brings me now to our course and how we've constructed a course that is going to address some of these challenges and goals. You can see from this grab that we're concerned with delivering a training program that prepares graduates for the creation and management of the food supply needs of the future. Some would say that the future has come to us, and you may have heard commentary about how the COVID pandemic is already impacting the food supply, particularly at the retailer and consumer end. Indeed, we're already seeing evidence of the food industry innovating to meet consumer needs. So that's an example of how fast the food industry and supply has to the pressures and challenges at hand. So let's go into a bit more detail about our course. The course is going to be run generally at Clayton, some exceptions for the business units which are taught at the Caulfield campus. We have either a 2-year full-time or a 4-year part-time course with the possibility of faster completion if you have approved credits based on your previous studies. You need to get in touch with myself to discuss how your previous studies might impact on your course map, and most likely if you have appropriate credits to shorten the time of study. And you can see we've moved now to 2 intakes a year, and having the next intake of students will be in in semester 2, starting in August. So again, we need to explain how this course map would affect you if you wish to commence in semester 2. It does mean you would undertake the different parts of the course in a slightly different sequence, but there's no advantage or disadvantage either way, and you may have a preference that we can discuss. So this brings me to the prerequisites for entry into this master's course. Apart from completing an undergraduate degree with a credit average, the only prerequisite is that you've completed first-year chemistry or equivalent. And again, you should contact us to see if your undergraduate course will be acceptable. The chemistry prerequisite reflects that the science components of the masters are taught at postgraduate level, although in a very applied way. Okay, so what about the broader content of the course? So as I explained, the course will equip you with the knowledge and understanding surrounding the 7 IUFOST missions, although it's probably fair to say that this one around big data is not a major focus of our course. But keep in mind that at Monash, students can opt to take what we call selectives, and these are master's level units from other master's courses. So there's a very wide range of existing units to choose from and new units under development. Okay, so this is a course designed for the future. We've tried to develop such a course, and what we mean by this is to recognise the special aspects of studying food in terms of the significance for either human survival, for trade, for employment, etc. And we know that food is cross-disciplinary. We know it is fast-moving and a low margins industry, and therefore needs to keep pace with technology and to innovate appropriately. We know that it has a complex supply chain, a very wide number of stakeholders with competing and complementary expectations and motivations. And we know that this means there are broad opportunities for employment. So we want to make sure that the perspectives and intersecting interests of different stakeholders are explored and recognised. And that's a very common theme in the way we get students to analyse information. So we want graduates of the course to be comfortable in the technical, commercial, even ethical aspects of food, and we are aiming high for your success with the design of this course. So here are the list on the right of possible roles and employers we anticipate for our graduates, and you can see that they're not all technical or about food science. So as I said, this Masters is geared to preparing graduates for success in many possible pathways, and these reflect the wide range of stakeholders in food, i.e. industry, government, consumers, etc., etc. But how do we do it? So another feature of the course is how we teach. So without losing sight of information and application skills, as educators, we now know that expectations of employers are growing in the space of interpersonal competency, creativity, and problem solving. And we develop these skills through interactive learning and problem solving. And furthermore, we invite professionals and authentic on-the-job, with authentic on-the-job experience to teach and share their knowledge. And we assess learning in ways designed to develop these success skills. And this is the growing demand of employers and expectations of employers and what's required for success. We also know, and in case you were wondering, about how our Masters is distinct from other courses that are running in Melbourne and in Australia. And we would say that the course is focused on the food supply chain from post-farm gate to consumer. And this allows for the important consumer and retail angle, which is taught by my colleagues from Monash Food Innovation. A second aspect of its differentiation is that it is a truly cross-disciplinary course covering science, nutrition, business and marketing. And it has an elective content, which is a one semester set of units tapping into active research in progress, or research and expertise, I should say, in progress at Monash, and therefore you won't find anywhere else in the world. The choice then finally of a one semester long research project or internship, with the latter supported by national and international contacts of Monash Food Innovation. So we have again a set of Monash professionals who will place students into internships in accordance with their interests, preferences and skills. So let me go now into a little bit more detail about the structure of the course. You can see that we have a 4-part course, A, B, C and D, and if taken consecutively, this will take up to 2 academic years. In general, we have Part A running in semester 1, Part B semester 2, and so on. We are going to be running this Part D in both semester 1 and semester 2 to give flexibility for students who enrol mid-year. For those who commence in semester 2, we recommend the sequence of Part B followed by Part A and then Part D followed by Part C. So that's as distinct from A, B, C, D. So for those who have some credits, we would need to sit down and plan your course map, and this would include some selective units from other master's courses, sorry. Okay, so a little bit more detail now, zooming in on the course structure. The way, it's a very simple structure. We have 7 units based on the core disciplines across food science and agribusiness. And these cover food chemistry, biochemistry, food engineering, food microbiology, food nutrition, consumer-focused innovation, which is marketing and supply chain, and the future of the food supply. So this is all the future kinds of ways we're going to be obtaining proteins or other nutrients and how we're going to be producing them. We have one collective practical unit that has representation of all of these activities in the first year. We then follow on with our Part C, and what this is students select 4 out of 7 what we call advanced units, permitting their specialisation in the disciplines of preference. So what I forgot to explain is our Part C electives are an advanced version of each one of these 7 units. All right, so they can be studied. They're compulsory at a core in the Part A or B, but when you get to Part C, you pick 4 out of 7 of these elective units, and optionally with a selective unit from another master's course as well. And then finally, students will take Part D, which is either a research project or an internship project that could be based off-site. So look, that brings me to the conclusion of what I'm presenting here tonight. Here are some links for information to support your enrolment. And just note that there is a one-off bursary available in 2020, which lowers the course content by $8,000. So if you have any questions, please direct them to myself or to my course coordinator, Shanaz Mansouri, and we are very happy to help. So that's all.
Everyone, I'd like to introduce you to Professor Tony Patti, who is the course director for the Master of Green and Sustainable Technologies. So I will hand it over to you, Tony.
Thanks, Kim, and good evening, everyone. Thanks for joining. My name's Tony Patti, as Kim's already said, and I'm a member of the School of Chemistry, an academic in the School of Chemistry. I'm also fairly recently become the director of a new ARC training centre with the title Green Chemistry in Manufacturing. So this new course that I'm really excited to tell you about is quite strongly affiliated with that new training centre as well. The training centre is about PhDs in research, and this course I'm telling you about is a master's program. So just to kick things off and to put things into context, I've got a whole lot of pictures here that I've thrown up, and I've called it, as you see there, chemistry is central to our lives. Now, if you think of all the different images that these photos throw up at you, we've got medicines, we've got mobile phones, we've got travel, we've got cars, we've got our containers and packaging, plastics, if you like. We've got agriculture, food, water, home furnishings, supermarkets, fuels, houses, what goes into houses, paints, concrete. Everything there is dependent on chemistry in some form or another. And everything there comes from a manufacturing process, or growing plants for our food, sustaining the crops through fertilizers and chemicals, agricultural chemicals. So our world, the world we're so used to and take for granted, is pretty dependent on chemical manufacturing in one way or another. And if we think about this in a broader context, and we think about climate change, and we hear a lot about sustainability and mitigating the issues we're dealing with in the world today around climate. Why have we got into this situation on our planet? Primarily because manufacturing things, we use energy, we want to make things, we want to continue the lifestyles we've been accustomed to, particularly in more developed countries, and the rights of underdeveloped countries to have the same. And all that manufacturing is what's drawn on our energy and really pushed the resources of our planet to the extreme. So this is where green chemistry comes around. So this course that I want to tell you about is really a course in green chemistry and related technologies, and hence the title Master of Green and Sustainable Technologies, but it's heavily focused on chemistry and the technologies that are affiliated often in some way or another where chemistry has a role. And what I've shown on this slide is a very broad brush definition, because people might well ask, well, what is green chemistry? Well, it's all about designing chemical products, processes, the things we enjoy, those things we take for granted in our society that are in our homes all around us, and to make those products and to have processes that don't give us the environmental problems, are sustainable in a green sense. Of quite often people confuse what's green and what's sustainable, because things that are sustainable are not always green. But we're putting the two together in this course and saying, can we make things from renewable feedstocks using minimum energy, think about the life cycle, think about circular economy, and in that way we're going to produce all those items in a way that gives our planet a better future for the generations to come. So in that context, this course is really about, and this is a slogan used in green chemistry thinking, everything is benign by design. I think that makes sense, I hope. And when we think of it that way, we think that the benefits come not only from the environment, but they come from economics and they come from social benefits as well. And now we hear a lot about the Sustainable Development Goals of the UN. And there's been now a number of recent papers and publications saying that green chemistry thinking is central to addressing UN Sustainable Development Goals. And some of these are quite obvious, things like responsible consumption, having resources that are renewable, have minimum impact on the planet. If you start to think of that, think of these things that are in those Sustainable Development Goal visions, green chemistry is going to have a big role to play. So our course then is about training people, preparing people for careers that will be addressing these issues, and it's of course got a focus around the chemistry side of things. I guess as the course develops in the future, we may well introduce other specialisations, but for now it's very much around the chemistry specialisation. Why would you choose the Monash's program in the States? Most of you probably appreciate Monash is an international university, and we are ranked in the top 100 of world universities in many of the ranking systems. We've had a long tradition of green and sustainable chemistry research that goes back 20 years. This course is the first we know of in the Southern Hemisphere with the focus in this area. There are several in the Northern Hemisphere, but ours is slightly different to those. We hope it'll be something that's attractive and better. We have very strong industry links in this course, and our new training centre, Green Chemistry and Manufacturing, is going to help us enormously to consolidate and even build on those links. And of course, Monash has great facilities and academics of international standing. And the nice image you see in the background here, that building is indeed, in fact, our Green Chemical Futures building. So if you're coming to Monash to do that course, the chances are you'll spend some time in that nice building. So who's the course for? What sort of backgrounds are we expecting? Well, it's really building on backgrounds that are already science-based and have some chemistry, but we don't expect you to be coming into a course like this being experts in chemistry, because that's what the course is going to do. It's going to build the chemistry side for you. If you have chemistry, then you've got some advantage in terms of prior standing, and I'll come back to that later. But I've listed there the backgrounds of people that could come into this course, and you'll see it's quite widespread. Anything from a traditional chemistry degree through to ag science, through to biotechnology backgrounds, health-related areas. It's very broad. So where chemistry is a component of many programs, it doesn't have to be the total focus, then this course is probably one for you. How are we going to deliver this course? Well, I'll show you some of the units or the subjects in a moment, but it's going to be a combination of blended learning. So we will have some online, some face-to-face. We're looking at models where we can offer some block teaching, and that will make it easier for people that are based in industry to attend, or even based outside of Australia to attend for shorter periods. We're hoping that some of the block components will be able to be offered in short course mode, which hopefully will appeal to people in industry where you're looking for particular topics, and based on your circumstances, you may be able to then cobble together enough credits to take towards a master's program. There will be a very heavy emphasis on interaction with industry and expertise coming from industry, and case studies coming out of industry. And while I'm on industry, I should say that some of the major chemical companies now, not just major chemical companies, it's companies that you don't normally associate directly with chemistry. If I think of, I'll give an example like Nike or Adidas. A lot of those companies now are trying to think about where they're sourcing their materials from and the product they're producing, which, as we've said, often rely on a chemistry manufacturing process. Are they coming from green and sustainable renewable sources? And the major chemical companies of the world and the pharmaceutical companies also are looking very hard at their manufacturing processes. How can they be greener? How can they be more sustainable? And what's been found is where companies have moved in this direction, they're actually becoming more profitable. And that needs people with the right backgrounds, right skills to try and move those companies into those spaces. So we're thinking about our chemistry and chemical manufacturing in a different way in this course. The degree will have some multidisciplinary contributions. So engineering and the business faculty are involved in offerings, and in some of these are through, and also I should have added arts there. There's some electives from the arts faculty being included. We will be quite openly looking at some of the UN Sustainable Development Goals and what the role of chemical manufacturing will have in the future in addressing those goals. And we're, as I've already said, we're already finding this increasing demand from industry for greener processes. So just like a few years ago, we had this interest from companies looking at their energy energy and manufacturing are obviously interconnected, and now companies are thinking about their actual processes more than just the energy side, but they're thinking about the inputs of materials, and do they satisfy green principles, and do their processes satisfy green principles? So in moving into this area, you would be looking at careers in industry, obviously in the industries that are highly involved in manufacturing, but also non-government organisations and organisations like the where opportunities for change are needed, particularly with links to manufacturing. Some of the expertise, we already said it's going to be heavily chemistry and some engineering focus. The engineering will come in through the electives that people may choose. An important feature of the program is internships, and we'll have quite an opportunity for doing internships. They can be done within the company if people coming in are working for a company already, or we will organise placements within companies and or suitable research organisations, and some of those are listed there. I won't read them all out. You can see them for yourself. An important part of this is really thinking that we'll be training people that will be able to help transform chemical industry or transform manufacturing ideas where chemistry is involved for the future for a better society. The structure of the course, just to give you different options this course has, it will be offered out of Clayton campus, although some of the units that or subjects run by business faculty may be at Caulfield, I'm sorry. It'll depend on choices that people make there. You have flexible entry points. So if I start at the top, if you've got a background in a STEM area, but not with a strong background in chemistry, then you're probably up for the full 2 years of the program. So the entry point there is that you have at least the equivalent of first year chemistry studies, and from that you would get, you would need to probably then do the full 2 years to bolster your chemistry background. And we expect a 60% credit average for entry, and normally we'd look at the final year of your first degree for that average. If you already have a background in chemistry, and it's a solid background in chemistry, then the course can be completed in 1.5 years. Again, the 60% credit average applies. For people who've done honours at Monash, and they have, I'm sorry, it's been chopped off the bottom of the screen there, but what it says there is that if they have done a research project in green chemistry, and some of the subjects of our new masters will be available to honours students, then they can effectively get a full year of credit towards the masters. So I'm speaking primarily for people who came through Monash, a Monash program, but if there are equivalent programs elsewhere that satisfy those requirements, we would then seriously look at the maximum amount of credit that could be granted into the program. We will have the opportunity to start in both semesters, semester 1 and semester 2 in 2021 when this new degree will come to fruition. Just in terms of the course structure, course structure is reasonably flexible, and I've put some boxes around the different parts of the structure. So part A is something that, those 4 units are something everybody has to do. So you'll be doing fundamental principles of green chemistry, then green chemistry, transforming industry and manufacturing. That is a subject unit that's going to be offered with the business faculty. In fact, the business faculty take a leading role in that unit. So you'll get quite a bit of training in understanding business principles and how changing business practices can be brought about through good understanding of the technical aspects. That will then prepare students to go into a green chemistry consultancy project where you'll be working with industry on an actual consultancy project, and people who are already based in industry will be able to take advantage of that situation to do that. In that context, that is going to be done as a group project, but it still will enable the work to be done in industrial setting. Part B is for people who have not done sufficient chemistry and need further background in chemistry. So they will be able to choose from a number of our undergraduate units, normally second and third year, and build their chemistry background. So that would be for people primarily who need to do the full 2 years of the course. Part C gives you further studies, specialist studies in green sustainable technologies. So we have 2 compulsory subjects, designing safer chemicals and green chemical synthesis applications. They're compulsory. Then students can choose from a variety of electives, and I haven't listed all the ones available. You'll see quite a range of electives, and they can be chosen according to particular interests and backgrounds people wish to gain experience in. And finally, the Part D of the course is linked around either an internship, which is a 12-point or effectively a quarter of a semester, sustainability project, which is a small project, so half a semester project, or alternatively under B, they can do a full research project, which is, again, it's been cut off. It can be done over 2 semesters for 24 points, or it can be done in 1 semester for 24 points. And entry points into these different parts of the course are quite flexible. Next year, we will definitely have Part A available, and the electives of Part C available, and the Part D advanced practice subject units are available. So summarising the key features of the degree, I mentioned the 3 entry level. Part-time is also available depending on individual circumstances. Strong links with industry through the internships and research, and of course the research component, if people do a full semester or 24 points of research, that will be sufficient to qualify them to be considered for PhD entry, subject to getting a good grade to be considered for research opportunities. A strong emphasis on building the skills in green sustainable chemistry linked to business principles, which will come through both the formal units, consultancy and internship, so that you can lead change in organisations, lead change from within, and also lead change in if going into other areas such as government, EPA, other organisations that influence what's happening in the manufacturing sector. I mentioned the electives. It is a pathway to PhD, and ultimately it's a great way to get a qualification where you can make a difference in a satisfying career. And I've already mentioned, for example, UN Sustainable Development Goals leading change. How to apply? Kim, who's hosting our session, is a contact. I've got Kim's email there. My email is there. We don't have a website. It's pending. It's coming, hopefully in the not too distant future. And the bottom website is a link to our just live today, our Industrial Transformation Training Centre website. Green Chemistry and Manufacturing just came to life today. There will be a link to education in that website, which will refer you to this new course.